Hello, grateful. How are you? Are you okay? I hope so. Today we will talk about probability. Probability events are either certain, impossible, or possible. The probability of certain event equal 1. Probability of impossible event equal 0. Probability of possible event between 0 and 1. Now try to solve drill 1. Complete and choose the correct answer. Put check, okay, as the example. This table indicates event, probability degree, probability of occurrence. Example: sun rises from east. This event is certain, so its probability is 1. People ride a bike to school. This event is possible. People may ride a bike and may not ride a bike. Maybe or maybe not. Okay? So it's event, it's possible event. Okay? Its probability between 0 and 1. Next event: family visit the seashore every year. This event may be or maybe not. So this event is possible. Its probability between 0 and 1. The next event: man lives on earth forever. Man can't live on earth forever, so this event is impossible. Its probability is 0. Next event: day comes after night. This is fact. This is true. Okay? So this event is certain. Its probability is 1. The last event: weather is sunny tomorrow. This event may be or maybe not. So this event is possible. Its probability between 0 and 1. Now go to drill 2. Let's read story problem. The weather forecast Pure. Pure means department. Expected that there will be a chance of a sunny day tomorrow with ratio 0.8 tenths, and that ratio will change for after tomorrow with a ratio 3/4. Expected for tomorrow with ratio 8 tenths. Expected 4 after tomorrow with ratio 3/4. Which of the 2 days will be of greater probability of being sunny? Tomorrow or after tomorrow? Note for you. 0.8 equal 0.80, 80 hundredths. 3/4 we need to convert the proper fraction to decimal fraction and to decimal number, okay? 3/4 equal, we can make 4 to be 100. 4 times 25 equal 100. 3 times 25 equal 75. 75/100 equal 0.75. 75 hundredths. Now we can determine which day has greater probability of being sunny. Tomorrow, its ratio 80 hundredths, 0.80. But after tomorrow, with ratio 0.75, 75 hundredths. Which day is the greater? Excellent. Tomorrow will be of greater chance of being sunny. Now we will learn how to calculate probability. Dread 1. Kamal spin a coin 100 times. He got hit 45 times. This is hit, okay? He got hit 45 times. What is the probability of getting head or tail? Its solution: possible events are either head or tail. The event of getting head or tail, this event is possible, okay? Maybe head, maybe tail. As in his experiment, okay? In our story problem, Kamal spent 45 times head, okay? So, to calculate its probability, we will do as follows. 45, this is number of times, head times, okay, over 100. 100, this is the total number of times, okay. To calculate the probability of head, we will do as follows. Put 45 over 100. 45, this is the number of head times, okay? 45. 100 is the total number of times, okay? 100 times. equal 45 over 100. This is decimal fraction equal 0.45. This is decimal number. The number of times he got tail. To calculate the number of times he got tail, we can do as follow. Equal 100 the total number of times minus 45. This is the number of head times. Equal 100 minus 45 equal 55 times. This is the number of times he got tail. Okay? Now we can calculate the probability of tail as we done before. Probability of getting a tail equal 55 over 100. 55, this is the number of tail times. Okay? 100, this is the total number of times, equal 0.55. What do you notice? We will observe the probability of getting head or tail. Or means plus, or means and. Okay? To get probability of getting head or tail, we will do as follow. Probability of getting head equal 45 over 100 plus probability of getting tail equal 55 over 100 equal 45 plus 55 equal 100 over 100. 100 over 100 equal 1. Now we will observe this rule. The sum of probabilities of all possible events equal 1. Again, the sum, this is the sum, okay, of probabilities, the probability of getting plus probability of getting head plus probability of getting tail, the sum of probabilities of all possible events. We know coin has possible events, maybe head or maybe tail. Okay, this is all possible events, head and tail. There is no another event. Okay, so 45 over 100 plus 55 over 100 equal 100 over 100 equal 1. Probability of getting head plus probability of getting tail equal 1. Again, the sum of probabilities of all possible events equal 1. Now we will solve drill 2. Shireen had a box of pens in which there were 100 pens. All pens fell on the floor. Some stood on their bases like this, and others fell tilted like that. If the number of tilted pins were 35 pins, 35 pins like that, calculate the probability that a pin falls on its base. like that. Okay? Its solution: the possible events are either the pen is on its base or tilted. Okay? The event is possible. Either the pen is on its base or tilted. Property to be tilted as in the experiment equal the total number of pins tilted over the total number of pins. 35 over 100 equal 0.35. Property to be on its base as in the experiment equal to find the number of pins on its base, we will do as follows. The total number of pins minus number of pins tilted equal number of pins on its base. Okay? 100 minus 35 equal 65. To get the probability to be on its base, we will do as follows. 65 over 100 equal 0.65. Another solution: the possible events are either the pen is on its base or tilted. Property to be tilted as an experiment equal 35 over 100 equal 0.35. Okay, as we done before in the first solution. Now we can get the probability to be on its base as in the experiment equal 1 minus 0.35 equal 0.65. Please take care. Are you remember the sum of probabilities of all possible events equal 1? Excellent. All possible events may be tilted or may be on its base. So we can get probability to be on its base equal 1. It's the sum of probabilities of all possible events. Okay, minus 0.35. This is the probability to be tilted equal 0.65. This is the probability to be on its base. Drill 3. Consider all possible outcomes have the same chance of occurring. Complete. Probability of appearance of head or tail when tossing a coin equal. We know the event of getting head or tail. It's possible. The sum of probabilities of all possible events for tossing a coin equal 1. Now we have two chances, maybe head, maybe tail. So the probability of getting head equal half, and also the probability of getting tail equal half. Half plus half equal 1. 1 is the sum of probabilities of all possible events for tossing a coin. Next one, probability of getting any number on the upper face when rolling a dice. We know dice has 6 faces. Numbers on faces may be 1, 2, 3, 4, 5, 6. Okay? Probability of getting any number on the upper face when rolling a dice equal 1 over 6. 1 is the number on the upper face, like this. We have only one face, has 4. Only one face has number 4, so its probability equal 1 over 6. We know we have only number 5 on dice, so the probability of getting number 5 equal 1 over 6. Probability of getting any number from 1 to 6. Its probability may be 1 over 6. 1, this is the number on the upper face. 6 is, we have the dice has 6 faces, the total number of faces, okay? The next event, the figure opposite, show a disk. This is a disk divided into equal sectors. Divided into equal sectors like this. Numbered from 1 to 10. Numbered from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Probability of the pointer pointing at one of the sectors. For example, number 7. If the pointer, like this, point at number 7, its probability of getting number 7 equal 1 over 10. We have only one sector with number 10. We have only one sector with number 7. So we will write 1. Only one sector with number 7. Over 10. 10, this is the number of all sectors. Okay? If we need to get probability of the pointer pointing at number 9, okay, its probability equal 1 over 10. 1, this is, we have only one sector with number 9. 10, this is the total number of sectors. Okay? Are you understand? Drill 4. A box contains 5 identical balls. Identical balls means balls with the same size. Okay? 2 of them are blue. 2 are blue, and 3 are red. If a ball is drawn blindly, what is the probability that it is red. Its solution: probability of being red equal number of red balls over total possible outcomes. This means total number of balls, okay? Equal 3. This is the number of red balls, 1, 2, 3, over total possible outcomes means total number of balls, 1, 2, 3, 4, 5, 3 over 5. We need to convert the proper fraction to decimal fraction, okay? 5 will be 10. 5 times 2 equals 10. 3 times 2 equals 6. This is decimal fraction. 6 over 10. Its decimal number will be 0.6. 6 tenths. Let's solve drill 5. A box contains 4 blue balls, 2 red balls, and 3 green balls. All balls are equal in size. If a ball is drawn blindly, complete. The first one, probability of drawing a blue ball equal number of blue balls, 1, 2, 3, 4. 4 over total number of balls, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability of drawing a blue ball equal 4 over 9. We can't simplify this fraction. The second one, probability of drawing a red ball equal number of red balls, 2, 1, 2, over total number of balls, 9, 2 over 9. This fraction, we can't simplify it. The third one, probability of drawing a green ball equal, we have 3 green balls, 1, 2, 3, over 9. 9 is the total number of balls. We can simplify this fraction in the simplest form. 9 is divisible by 3. So 3 divided by 3 equals 1. 9 divided by 3 equals 3. Third is the simplest form. The fourth one, probability of drawing a non-blue ball. Non-blue ball means all balls without blue. We can find it as follows. 1 minus number of blue ball are 4 over 9. 1 means 9 over 9, all balls, okay, minus number of blue balls, 4 over 9, its probability, okay, equal 5 over 9. 5 over 9, it's the probability of drawing a non-blue ball. Okay? This fraction, we can't simplify it. The fifth one, probability of drawing a non-red ball equal non-red ball means all balls without red. Okay? Equal 1. 1 means 9 over 9. Minus 2 over 9. 2 over 9, the probability of red ball. Okay? Equal 9 minus 2 equals 7 over 9. 7 over 9, it's the probability of drawing non-red ball. We can simplify this fraction. Let's solve drill 6. You have identical cards with the numbers 1, 4, 6, 8, and 10 written on them. If one card is drawn blindly, what is the probability of having a number between 5 and 9? Look, these are cards with numbers 1, 4, 6, 8, and 10. We need to find the probability of having number between 5 and 9. We need number between 5 and 9. Look at the cards. After 5, there is 6 and 8. Take care, we need number before 9. So we can't use 10. The probability of having 6 and 8. Probability of having a card with a number between 5 and 9 on the drawn card equal. We have two numbers between 5 and 9. So we will write 2 over 5. 5, this is the total number of cards. 1, 2, 3, 4, 5. 2 means we have two cards with numbers between 5 and 9. 5 means total number of cards. Okay? Now we need to convert proper fraction to decimal fraction. 5 can be 10. 5 times 2 equals 10. So 2 times 2 equals 4. Decimal fraction can be written as 0.4, 4 tenths. Its probability of having a card with number between 5 and 9 in decimal number 0.4, 4 tenths. Let's solve some extra problems. Box contains 5 red balls, 3 blue balls, and 4 green balls. All balls with the same size. A ball was drawn blindly. Complete. Please take care. total number of balls equal 5 plus 3 plus 4 equal 12 balls. The first one, probability of being a blue ball is 3/12. We can simplify this fraction. 12 is divisible by 3. 3 divided by 3 equal 1. 12 divided by 3 equal 4. We can write this fraction in decimal fraction. 4 times 25 equal 100. 1 times 25 equal 25. So the probability of being a blue ball is 0.25. 25 hundredths. Next one, probability of being a non-green ball is 1 minus 4/12 equal 8/12. We can simplify this fraction. The common factor between 8 and 12 is 4. 8 divided by 4 equal 2. 12 divided by 4 equal 3. Take care, we can't write this proper fraction in decimal fraction. We can't. There is no friends for 3. Okay? The next one, probability of being either red or green ball is, or means plus, probability of being red 5/12 plus probability of being green 4/12 equal 9/12. We can simplify this fraction. The common factor between 9 and 12 is 3. 9 divided by 3 equals 3. 12 divided by 3 equal 4. Take care, we can write this proper fraction in decimal fraction. We know friend of 4 is 25. 4 times 25 equal 100. 3 times 25 equal 75. So the probability of being either red or green ball is 0.75. 75 hundredths. Choose the correct answer. The first one, the probability of the impossible event. Excellent. 0. The next one, the probability of the certain event. Equal. Excellent. 1. The third one, the probability of the certain event space the probability of the possible event. Please take care. Probability of certain event equal 1, but probability of the possible event in the form of fraction. Fraction is smaller than 1, so we will put here greater than. The next one, the probability of a possible event may be 1, no. 1.5, no. 0, no. Maybe 1/3. 1/3, this is fraction. Okay? Again, don't forget, probability of possible event may be. Possible event means its probability in the form of fraction. Okay? 1.5 is greater than 1, is greater than fraction. So we can't use 1.5. So the correct answer is third, 1/3. This is fraction. The next one, when you flip a coin once, the probability of getting a tail. Excellent. Half. The next one, when you throw a dice once, the probability of getting the number 3 is. We know we have only one face with number 3, so its probability will be 1/6. We have 6 faces. We have one face with number 3. The next one, when you draw a card from 8 cards numbered from 1 to 8, the probability of getting the number 4 is. We know there is only one card with number 4, so the probability will be 1/8. The last one, a basket contains 5 white balls, 3 yellow balls, and 2 green balls. If you draw one ball, the probability of getting white ball equal white balls 5. So its probability will be 5/10. Total number of balls 5 plus 3 plus 2 equal 10. So its probability will be 5/10. We can simplify this fraction will be half. Correct answer will be half. Now we will start think exercise for you. Look at and then complete. The probability of the drawn ball being red. Look at. There is 4 red balls. Total number of balls 1, 2, 3, 4, 5, 6, 7. So the probability of the drawn ball being red equal 4/7. We can simplify this fraction. We can't convert this fraction into decimal fraction. The probability of drawn ball being yellow. We have 3 yellow balls, so its probability will be 3 over 7. We can't simplify this fraction. We can't convert this fraction into decimal fraction. The last one, the probability of the drawn ball being blue. Please look at this figure. We don't have any blue balls, so its probability will be 0. Extra one for you. When a die means dice, is rolled once and the upper face is observed, find the following probability. The first one, appearance of an odd number. Odd numbers on dice are 1, 3, and 5. So the probability of appearance of an odd number equal 3 over 6. We have 3 odd numbers, 1, 2, 3. 3 over 6. 6 is the total number of faces. We can simplify this fraction. 6 is divisible by 3. 3 divided by 3 equal 1. 6 divided by 3 equal 2. So the probability of getting an odd number equal half. The second one, appearance of an even number. Even numbers on dice are 2, 4, 6. So we have 3 even numbers. Its probability will be 3 over 6. We can simplify this fraction. Will be half. The third one, appearance a number less than 4. Numbers less than 4 on dice 1, 2, and 3. There are 3 numbers less than 4, so its probability will be 3 over 6. We can simplify this fraction to be half. The fourth one, appearance a number greater than 4. We know there are 2 numbers greater than 4, 5 and 6. So the probability of getting a number greater than 4 equal, we have 2 numbers, so 2 over 6. We can simplify this fraction. 6 is divisible by 2. 2 divided by 2 equal 1. 6 divided by 2 equals 3. So the probability of appearance a number greater than 4 will be third. The fifth one, appearance the number 7 equal, we know there is no number 7 on the dice. Only on the dice there is 6 faces. We can't find number 7. So its probability will be 0. The last one, probability of appearance the number 1, 2, 3, 4, 5, 6. Take care. These numbers are all numbers on the dice. All numbers on the dice. So its probability will be 6 over 6 equal 1. Extra one for you. Choose the correct answer from those between brackets. The first one is tossing a metallic coin once and observing the upper face, then the probability of appearing ahead. Excellent. Half. The second one, the sun rises from east, is a certain event. The third one, the probability of getting an even number when tossing a dice once, equal. Excellent. Half. The fourth one, the probability of the certain event, equal 1. Excellent. The fifth one, the probability of the impossible event, 0. The probability of the number 8 when tossing a die once. We know there is no number 8 on dice. The last number on dice is 6, so we can't find number 8. The probability will be 0. The seventh one, the probability of getting a number less than 3 when a die is tossed once, equal. Less than 3, we have two numbers, 1 and 2. 2 over 6. We can simplify this fraction to be 1 over 3. Third. The correct answer will be third. The last one, the probability of getting a number less than 1 when a die is tossed once, equal. We know on dice there is no number less than 1. So we can't find number 0 on the dice. So its probability of getting a number less than 1 will be 0. Please take care. The word less than, we can correct the wrong letter, than, T-H-A-N. Okay? We can correct the wrong letter, than, T-H-A-N. Good time for you. Goodbye.